When you think of public infrastructure, you probably think of roads, bridges, and possibly water towers. These often massive structures are a staple of 21st century urban planning. They're all around us, but have you ever stopped to think about how and why they work? We can all likely understand that water towers hold significant amounts of water high up in the sky, but their usefulness and engineering intricacies go much further than this. Water towers and their siblings, known as standpipes, come in all sorts of different sizes and shapes, each with roughly the same goal: to keep water networks pressurized. Many water towers function simply as open-flowing holding tanks to pressurized water systems. This means that there often isn't a pump directly next to the water tower pumping water up to the top. This, however, is accomplished by the already present pressure in a water system from pumps back at the source of the clean drinking water. For example, if a pipe network were pressurized to 50 psi or pounds per square inch, then the system would be able to push water 115 feet into the air, storing it in the water tower tank. This elevation of water as a result of the pipe network's pressure is called head. Each psi of pressure is equivalent to about 2.31 feet of head. Using this simple calculation, engineers can determine the proper height to design water towers to and their storage capacity based on normal pipe network conditions. Now that we have that simple understanding out of the way, we can start to grasp the overall picture. Most water towers are pretty simple machines. Clean water leaves a water treatment plant and is pushed into the network using a series of main pumps. These pumps place pressure on the water system, allowing it to flow to all the necessary outlets, including inside water towers. A standard water tower might hold in the range of 1 million gallons, but their capacity varies greatly depending upon system requirements. As we said before, each psi of pressure before a water tower can push a column of water up about 2.31 feet. When the water leaves the water tower, each foot of water converts to 0.43 psi. So, if a water tower is storing 100 feet of water, then it could supply 43 psi of pressure into the system. We've got the basics of how water towers function out of the way, but this doesn't answer the question of why. Keeping large quantities of water high off the ground plays an important role in regulating water pressure for cities across the world. Demand for water fluctuates throughout the day. During lunch or in the morning, more water may be required from the system based on user needs. Wastewater treatment plant operators can even tell when halftime at the Super Bowl is because of the significantly increased flow rate. All that said, engineers and operators try to keep the water system at a fairly constant pressure, or at least above minimum pressures for safety. Doing so with only pumps would mean significantly more energy usage during peak times and nearly no energy usage during off times, like in the night. Adding water towers into the system allows for the pumps to run at a fairly constant rate, with the stored water in the towers making up for peak times. During off time, the water towers will refill, acting as a buffer storing any excess energy in the system. Water towers not only act as a buffer, but they also help in times of emergency. Pumps, like any other machines, often break. Without water towers, this would mean entire networks could lose water pressure, potentially allowing deadly bacteria into the pipe network. Water towers allow for small periods of downtime on the pump end, often up to 24 hours, to help keep the system up and running. For all these reasons, most pressurized water networks since the late 19th century into today have used water towers in their designs. So, water towers function to regulate flow, decrease variable strain on pumps, store excess water supply and energy, and serve as backups in times of emergency. These structures are essential aspects of water networks in modern municipal infrastructure. You can think of these monolithic masts as great regulators in water supply systems across the world. Without them, engineers would have a hard time keeping your water free of bacteria and supplied to you at constant pressures. Thanks for watching.